Okay, so the last two topics, okay, when we learn on the Z distribution, okay, so we learn on how to calculate the probability under the normal distribution, okay, the area under the curve, and in the previous topic, we also look at the a short introduction on the T distribution, okay, the student T distribution, which is also a family under the normal distribution, okay, but uh, we use T distribution instead of the Z distribution if the standard deviation is calculated from the sample. Okay, and I also mentioned from the previous lecture that in the real world, okay, whenever you do research, it's very common that researchers, okay, academicians, whenever you do a research, okay, it's common that you will calculate the standard deviation from the sample itself, okay, not having access to information that relate to the population information. So the use of the T distribution is very common, okay, instead of using the Z distribution. Of course, you need to know both, okay, because in some cases, you still need to use the Z distribution. Okay, so what is this topic all about? Okay, estimation and confidence interval. Okay, so the past few syllabus, the past few topics, okay, whenever you have learned on the concept of mean, standard deviation, okay, the measure of central location, mean, mode, median, and then the measure of dispersion, variance, and standard deviation. Okay, and then we also look at in the previous topic, okay, what is the error term, okay, which is the difference between the estimated value and also the population value. For example, X bar versus mu. Okay, the difference between X bar and mu is what we call the error term. Okay, and then the difference between sample standard deviation and population standard deviation. So basically, whenever we rely on sample, okay, which is the purpose of the previous topic, okay, whenever we calculate or we rely on sample to represent the population, it is expected that the value of the sample will not be the same as the value of the population. When you calculate the mean of the sample, which is X bar, okay, when you calculate X bar, okay, X bar is supposed to represent mu, okay, which is the mean of the population. So let's say you get X bar equals to 10, okay, but it is not surprising, okay, if 10 is not equals to mu. For example, the mu of the population, let's say it could be 11, okay, but from the sample you get 10. So, but whenever you use sample, we expect that the sample value, whether it is X bar, okay, the sample standard deviation, which is to represent the sigma, the population standard deviation, we expect that this value of the sample, the value of from the sample that we calculate, whether X bar or standard deviation, is to represent the actual value of the population. Okay, if X bar is supposed to represent the mu, sample standard deviation S is supposed to represent sigma, which is the population standard deviation. Okay, so that is what we have covered so far. So in this topic, okay, when first we look at what is point estimate, which is we already covered this one actually, but we're going to define it again using this. In fact, I think in your quiz, okay, recently, okay, you have some concept on this point estimate as well. Okay, and then that will bring you to this concept of confidence interval. Okay, so recall just now, okay, whenever you use sample, okay, to represent a population, we expect that the sample value, the value of the sample to be as close as possible to the population. So that is the main purpose of doing study or research. Okay, because when you collect sample, okay, rather than using the whole population, okay, the reason we already discussed before, because of time constraint, okay, the cost involved, okay, to collect a big data set. So usually people will rely on sample, a much smaller size of sample data. Okay, so and at the end of the day, when you report your findings, okay, what is the conclusion that you get from your research, from your study? from the sample that you have collected. Okay, so whether people are going to believe or going to support your findings. Okay, so there must be, first you must follow the standard procedure on how to collect your sample. Okay, we also learned this very briefly. There are many methods to determine or to obtain sample, which is like the random sampling, cluster sampling, stratified sampling. Okay, there is a slide that we only cover very briefly on this. Okay, so at the end of the day is how reliable your sample is and how reliable is your results. So that will actually help you to understand the concept of confidence interval. Okay, so once we understand what is the concept or the purpose of confidence interval, then we're going to look at how to calculate confidence interval under two different scenarios. One, when the sigma is known. Okay, sigma is known means that we get information from the population. Okay, and then secondly is when the sigma is unknown, meaning we rely from the sample information. So this is similar to what we have covered in the previous topic. Okay, when sigma is known, we are going to use the Z distribution. When sigma is unknown, okay, the word standard deviation means standard deviation collected from the population. Okay, but when it is unknown, meaning you need to rely on the standard deviation calculated from the sample. Okay, so the word unknown here, okay, you can put in your bracket, you can edit in your notes. Okay, standard deviation unknown means standard deviation. So the standard deviation is taken from taken from sample. Okay, so that is another way to describe. Okay, whenever you see the word sigma unknown, so basically it refers to standard deviation taken from sample. Okay, rather than taken from the population. Okay, so of course, okay, again, in the real world, okay, usually sigma is not known. So usually people will rely on the sample information, meaning that whatever information that you get from the sample, so that will be used in your estimation. Okay, whether to calculate the probability, okay, or also to calculate the confidence interval as what is covered in this topic. Okay, and this last item here, the word proportion. Okay, so beside sigma in known and sigma is unknown, okay, we also have another concept or another angle, okay, or another perspective how to calculate confidence interval is based on proportion. Proportion means, okay, the ratio lah. For example, the ratio of male to how many male student, what is the ratio of male student in UUM? So meaning that the total number of male divided by the whole male plus female, then you get the proportion. Okay, so the word proportion basically refers to the in term of ratio lah. Okay, so there's nothing. So topic 9.5 and 9.6 here, I mean, there's from this. So to calculate the standard the confidence interval when it involves proportion. So this usually will involve the Z distribution, not the T distribution. So this one 9-3, okay. So this one is using Z distribution, okay. Meaning that when sigma is known, you're going to use Z. So when sigma is unknown, meaning you use the sigma, the standard deviation calculated from sample, meaning this is you're going to use the T distribution. Okay, so for population proportion, okay, usually we are going to use the Z distribution. Okay, so we're going to look at this concept this week. Okay, so hopefully by end of this week on Thursday we can finish both of these. I mean the whole of this topic. Okay, so point estimate. Okay, if you recall from the previous slide, I mean the previous topic, we look at the concept of error. Okay, the difference between the data that you collect from sample versus the actual information from the population. So the word estimate, okay, or anggaran. Point estimate means there's only one value. Okay, point estimate, not points estimate. Okay, point estimate is a single value derived from sample used to estimate the population value. So you calculate one particular value or a point value, which is supposed to represent the population information. So Okay, so you have looked at how to calculate the mean. Okay, the formula to calculate the mean from sample and the mean from population is exactly the same. Summation of x divided by n. Okay, so there is no difference. But between sample standard deviation versus population standard deviation, okay, we know that there is a slight difference in the formula. For sample, you need to divide by n minus 1. Okay, but for population, no need to divide by n, just divide by n. Okay, so you can refer back to your previous, I think in chapter 4, okay, when you calculate, in chapter 3, okay, when you learn how to calculate standard deviation from population and also standard deviation from sample. Okay, so basically the word point estimate is the use of the sample information to represent, okay, to estimate the population value. So this is what we are going to calculate. Okay, so you learn this part x bar and s. Okay, so s squared is just the square of s. Okay, but for proportion, okay, you are going to be introduced on this concept in this chapter. Okay, proportion is basically just the ratio. Okay, ratio or Paretos. Okay, so P is the point estimate or the symbol we use to represent pi. Pi is the population proportion. So P is the sample proportion. Okay, so we collect information from the sample. We calculate what is the proportion of that particular event that you want to calculate. So that proportion we label as P. Okay, the symbol used for the population will be pi. Okay. So that is on the concept of point estimate. So whenever you see the word point estimate, so basically this refers to the sample information, okay, to represent or to estimate the population value. Okay, so once you understand this concept, why we need to have this point estimate, because in the real world you cannot, okay, it's not objective or it's not possible. Usually, it's not possible to determine what is the population value. Okay, unless you do a census or bancian, meaning you collect information from every single individual. Okay, but in most research, okay, whenever you do a study, you do a survey, people will rely on sample data. Okay, you collect sample. From that sample, you're going to make your conclusion. So that conclusion is supposed to represent the population information. Okay, for example, now if you ask, let's say you do a simple survey. Okay, what is your opinion on how many of you agree or do not agree that you can balik kampung or cross states, okay, for this Hari Raya, for this Eid celebration. Okay, for example, I'm living in Kedah. Okay, let's say I want to go back to the south. Okay, to KL or okay to KL. Okay, so how many of you agree? How many of you do not agree? So if I do a simple survey, so that survey may only be answered, okay, by let's say few hundred students, or let's say 1,000 sample. So that 1,000 is supposed to represent maybe the opinion of the whole country, for example. So of course, the whole country involved, there are more than 30 million more than 30 million population. Okay, so if you want that information from every single Malaysian plus the foreigner who lives here, so it's almost impossible. Okay, so we need to rely on the information from the sample. So that brings us to this concept of confidence interval. The word interval means there is a lower boundary, there is an upper boundary. Okay, selang atas, selang bawah. Okay, interval. Okay, there is a lower value and also upper value. Okay, and then the word confidence lah, okay, from the English word, okay, how confident are you? Okay, selang in Malay we call it selang keyakinan. Okay, so if you read Malay textbooks, okay, so confidence interval is translated as selang keyakinan. Okay, so what is confidence interval estimate? So the word interval, okay, it refers to a range. Okay, so you have a lower value and also an upper value. Okay, constructed from sample data so that the population parameter is likely to occur within that range at specified probability. So what this one sentence means is that first you collect sample. Okay, so you collect your sample and then you calculate what is your X bar, for example, what is the mean value. Okay, so this mean value is your point estimate. Okay, and this point estimate is supposed to represent the mu, which is the population mean. Okay, but let's say just now, okay, we get the value of x bar equals to 10. Okay, and assuming that, let's say, the value of mu is 11. Of course, we do not know what is mu. If we already knew what is mu, we don't need to use sample. Okay, but the reason why we collect sample is that we do not know what is the actual value of this mu. Okay, so let's say that, okay, mu is equals to 11. Okay, x bar is equals to 10. Okay, so whenever you collect your sample, how confident are you that this 10, okay, is okay, so let's say is within how many percent? So let's say if after you finish your exam, okay, so let's say at the end of the semester, so let's say your parent asks you, okay, on one particular subject, let's say pengantar stat, okay, or BEQ, okay, basic statistics, okay, so your parent asks you, how confident are you that you are going to get an A for this subject? Okay, so usually, I mean, if you are really confident, let's say maybe for this kind of assessments, because you have, I mean, you don't have final exam, right? Okay, so let's say in a normal scenario where you have final exam, and after the exam, and your friend asks you, okay, how confident are you that that you have answered all the questions correctly? So if you are very confident, so maybe you can say that I am 90% confident. Okay, meaning that you are confident that all of the questions that you answered, okay, 90%, at least 90% should be correct. Okay, should be betul lah. Okay, or according to the syllabus or according to the answer scheme. Okay, but if you ask someone who have not prepared, okay, have not made the right preparation for the exam, okay, or let's say you spot another topic, but the one that come out in the exam is a different topic. So after the exam, you ask your friend, and your friend is not really confident. So let's say, and then how many percent do you think you answer correctly? So if you are less confident, of course, maybe you will downgrade from 90%. From 100%, maybe you can say that maybe I only answer correctly 60%. Okay, so this value of this value is basically how confident are you, okay, that the answers that you provided are correct, okay, according to the answer scheme, for example. So the same goes to our concept of confidence interval. So whenever you calculate x bar, okay, which is supposed to represent the mu, okay, so at the end of the study, okay, you can determine how confident are you that this x bar is how close is this x bar to mu. Okay, is it like 90% or 95% or 99%? Usually in statistics, okay, the higher is the I mean if you, the word confidence mean, the degree of your confidence level, okay, in terms of the the closeness of the accuracy of the x bar to represent the mu. So that is what is here, a range of values, okay, so constructed from sample data, so that the population parameter is likely to occur within that range. So meaning that, so let's say you have a lower boundary and also an upper boundary. Okay, so the word interval means there must be a lower value and also an upper value. Okay, so along this line, okay, you are confident that, okay, within this lower and upper value, so let's say my x bar is 10. Okay, correct. Okay, so my x bar is 10, let's say here. So this is my x bar, which is equal to 10. Okay, and my lower value, let's say this one is 8. Okay, and my upper value, let's say this one is 12. Okay, so so my point estimate is 10. Okay, but I cannot say for sure that 10 is exactly equals to mu. Okay, so this is not logical, or not whenever you do a research, you cannot say for sure my x bar is exactly equals to mu. Okay, but what you can say, what you can do is you can construct an interval, okay, from the sample value that you calculated, and you can give a range. So let's say from my x bar is 10, okay, my lower value, okay, of course you need to follow a certain formula. My lower value is 8, my upper value is 12. So I can say that between 8 to 12, okay, somewhere between 8 to 12, is the value of the mu. But whether mu is 9, whether mu is 9.5, whether mu is 10.5, 11.5, I do not know. But I'm sure, what I am sure is that somewhere between 8 to 12, somewhere between this range, so the value of mu is somewhere between 8 to 12. So of course, if we know that mu is 11, no need to calculate CI, okay, confidence interval. But so let's say that so mu is actually 11, so which is correct lah, okay, because when you calculate your confidence interval, you say that between 8 to 12. So it's just like when you take a Grab car or you are driving from point A to point B, and then you look at your GPS, okay, the condition of the traffic, and somebody asks you, okay, if you have an appointment, okay, what is your estimated time of arrival? So you can say, if you are confident that you can be there on time, so you can say that, okay, I will arrive maybe plus minus 10 minutes, okay? But if you are not really sure because there are heavy traffic on the road, okay, so you can, maybe your margin of error will increase. Okay, I will arrive there plus minus 1 hour. Okay, but if the road is becoming very, very bad, jam, okay, rain, hujan lebat, okay, rainfall, I mean raining heavily and everything. So all the bad scenario is happening at that time. So what is your estimated time of arrival? You say that I will be there maybe plus minus 3 hours, meaning you can be late up to 3 hours, for example, due to the heavy traffic. Okay, but if the road is very good, I mean, the road condition is very good, no jam and whatsoever, so you can see that I will be there plus minus maybe only 5 minutes or plus minus 10 minutes. So it's the same thing on this concept of confidence interval. The higher is the confidence interval, the smaller is the range. Okay, the lower is your confidence level, meaning that the range becomes bigger and bigger. Okay, so that is because whenever you do a research, okay, and you want to report your findings, okay, and you cannot say for sure, okay, that your value from the sample is exactly equal to the population value. So what is what people what academician researchers do whenever you rely on statistics, you will come up with using confidence interval estimate, meaning you are going to calculate the interval, and somewhere between the interval, you say that the value of the mu or the population parameter is somewhere along this within this range. So the formula for CI is basically the point estimate. Okay, you recall that here we have three parts, whether we are going to use the Z distribution, the T distribution, or the proportion. So here in our syllabus, this point estimate, usually we are only focusing at two part, which is calculating the point estimate. The point estimate will be either X bar or the P, the proportion. Okay, so X bar means we can either go using the Z distribution or the T distribution. Okay, but for proportion, okay, in this syllabus, we are going only to discuss using the Z distribution. So point estimate means the use of the information from the sample. Okay, here it refers to X bar, okay, X bar, and also P, okay, to represent the pie, the population proportion. And the margin of error, okay, so here you will look how to calculate this value of margin of error. So what determines the size of the interval? Okay, just now I mentioned that the size can be big, the size can be small. The interval, the selang, the upper interval and also the lower interval depends on the on this, okay, the sample size, okay, and also the value of sigma and the desired level of confidence. How if you are, from your findings, if you are highly confident, then this value will become higher, 95. So usually in statistics, the most common one will be 95%, will be 90%, it will be 95, and it will be 99. So these are the three common confidence interval percentage, okay, 90%, 95, and 99. Of course, you can calculate other values as well, okay, but whenever you do research, okay, or even if you use computer programs like eBuild, Stata, SPSS, okay, the common options provided in the software will be these three: 90, 95, and 99. So this is what we will be focusing. Most of the questions from the book, okay, will be focusing in these three values. Okay, so so the size of the sample size, the value of the sigma, or which is estimated by the sample standard deviation, and the value of and the degree of the confidence. Okay, so recall just now the formula is point estimate, which is the x bar plus minus the margin of error. Okay, so the margin of error is this part here. So first we start with sigma known. Okay, recall just now when I said sigma known, meaning that the sigma is taken from the population. So we are going to use the Z distribution. Okay, so this component here that you see, Z multiplied by sigma over n square root. So Z represents the Z distribution. So this part here is what we call the margin of error. Okay, ME, the margin of error. So X bar is the point estimate plus minus margin of error. So when sigma is known, okay, so we are going to use the Z distribution. So the margin of error is calculated based on the Z distribution. Okay, so the formula is very simple. Okay, everything will be provided from the information in the so meaning the X bar is whether you need to calculate X bar manually. The X bar is given, or you are given the raw data. Okay, as what you practiced before in the previous topics, you are given raw data. Okay, and then from that raw data, you can calculate what is your mean and what is also your standard deviation. Okay, but when sigma is known, sigma will be provided to you. So meaning that what you need to calculate is only the X bar. Okay, so X bar sample mean, Z is the value of the confidence level. So this will be determined, provided. Okay, and then sigma is the population standard deviation. Okay, why sigma, not S? Because here we mentioned that sigma is known. Okay, and N is the number of sample size. Okay. So in the previous two topics, okay, when you learn on the Z distribution, you learn how to use the Z table, okay, or the online calculator, okay, whichever method that you use, okay, to calculate the probability value. Okay, so you convert. So if you the step that we learned before, from X you convert into Z, or in the previous topic from X bar, okay, you convert into Z. Okay, when you use sample mean, we use X bar. In the previous topic, in the introduction, we use X minus from X we convert into Z. Okay, what is the formula to convert X into Z? Okay, X bar minus mu divided by standard deviation. Okay, so that is what you learned before, how to convert from X into Z. The same thing here. Okay, what is the Z value? Okay, so basically it brings, it refers to what you have learned before. Okay, so 95%. Okay, so this is something that you need to, once you understand this concept, so it will be quite simple to follow for the rest of the the rest of the topic. Okay, so if you recall just now, when we talk about confidence interval, okay, there is a lower value and also upper value. Okay, so in a normal distribution, whether Z distribution or T distribution, okay, recall that both are, the shape is the same, whether it's Z distribution or T distribution, both are asymmetric, meaning it is like an inverse U shape, okay, like a bell-shaped distribution. Okay, so meaning that you have the area on the negative side and the area on the positive side. So the word lower interval is referring to the area on the left side of the table, meaning on the negative side. Okay, the upper value will refer to the positive side, meaning you can see that's why this is minus, this is plus. Okay, so and then somewhere along this range, okay, if you recall just now, CI is about interval. Okay, so why do you need to calculate interval? Because we want to make a conclusion, okay, from the sample. Somewhere along this line between this value and this value is the value of our is the value of mu, the value of the population mean. Okay, so somewhere between this value, okay, but you cannot say for sure where is or what is the population mean. But once you calculate the interval, okay, the lower interval is on the left side of the upper interval is somewhere on the right side. Okay, so whether it is this value or this value, okay, depending on the confidence level value. Okay, so here, for example, we start with the most common one, 95% confidence interval. Okay, so you can see here that the formula is mu. Okay, if you recall that the formula is point estimate or x bar plus minus margin of error, correct? Okay, and the margin of error, if you refer to the previous slide just now, the margin of error is basically this part, z multiplied by sigma divided by n square root. Okay, so z in the next set just now, it shows to be as 1.96. Okay, so how do you get 1.96 in the first place? Okay, the rest will be given to you. Okay, sigma will be given to you, sample size will be given to you, x bar can be both, it can be given to you or you need to calculate from the raw data. Okay, but z, so z you need to determine from the table or from the calculator. Okay, so what will be given to you, not 1.96, but what will be given to you is the confidence value. So let's say you want to calculate a 95% confidence interval for that particular sample size. Okay, so how do you go about to determine what is the appropriate z value? Okay, from this confidence value, you can determine what is the z value. So here the z is shown to be as 1.96. I mean, of course, the value is 1.96. On the right side or the upper value is plus 1.96. But the main thing is that 95% for z value, 95% is equal to 1.96. So how do we get 1.96 in the first place? Okay, so basically it's the same thing as what you have learned when you look at the Z table. Okay, so okay, I will jump straight to the slide first. Okay, so that you can get some idea how do we get 1.96. Okay, so this is a bit for Z. What I can say, some of the common values you can memorize, meaning no need to refer to the Z table every time you want to calculate the confidence value. Okay, but for the T distribution, you cannot memorize, meaning that one changes according to the sample size. Okay, so first let me show how do you get 1.96. Okay, to be the 95% CI value. Okay, so if you look at here, 1.96, which is equals to 0.475. Okay, so just now we mentioned that 95% confidence interval. Okay, if you are using the Z distribution, the Z value will be 1.96. Okay, so how do you get 1.96? Okay, this is basically like a reverse process. In the previous two topics, you calculate the probability value. Okay, you don't determine. So meaning that from X you convert into Z, and once you get the Z, you determine what is the probability value, whether it is more than, it is less than, or it is in between two values. Okay, so that's what you did in the previous quiz or the previous test number 2. Okay, from X you convert into Z, and then from once you determine what is the Z value, you look at the equality sign, more than or less than. Okay, and then from there you will refer to the table or the calculator and determine what is the appropriate or the correct probability value under the curve. Okay, but here is the process is reversed, meaning that you know already the probability value. So once you know the probability value, what is the appropriate Z value that matches that probability value? Okay, so the process is from probability going back to Z. Okay, in the previous two topics, you calculate the probability, meaning from X you convert into Z, and from Z you determine what is the probability. So that is the general idea. Okay, so first, how do you get 1.96? Okay, so in the let me go back to this slide just now. Okay, so you can see that from here. Okay, this part. Okay, so 95%. Okay, 95% mean the range from. Oops. Okay, the range from the area under the curve, okay, when you say 95% CI, we are confident that, okay, so this range is 0.95. Okay, because when you say that I am 95% confident, okay, or you want to calculate 95% confidence interval. So the word interval means the area under the curve between the lower boundary and the upper boundary. This area is equal to 0.95. Okay, if this area is equal to 0.95, then from you know that the area under the curve refers to the probability value. So if this is 0.95, and you know that the figure is, this area is asymmetric. So you can divide 0.95 into 2. Okay, 0.95. If you divide by 2, what do you get? Okay, you can just refer to the calculator. Okay, 0.95. Okay, divide by 2. So that will give you 0.475. Okay, so 0.475 is the area between this and this. Okay, so one part of the graph is 0.475. Okay, so when you want to calculate 95% CI, 95% CI means the area under the curve between the lower boundary and also the upper boundary. Okay, so and because the area is asymmetric, you can cut the graph into half. Okay, because you recall that your Z table only reads you the right side of the area. So the right side of the area is equivalent to 0.475. So 0.475, so that's how you read the table in this slide just now. Okay, so and then from the table, you find what is the value that matches 0.47 or closest to 0.475. Because sometimes you don't get exactly the same value as your confidence value. Okay, but for 95%, you divide by 2, you get 0.475 on either side. So you look at the Z table, okay, from top to bottom, find the one that is nearest or exactly equal, and that value fall here, 0.475, which is equals to 1.96. So that's how basically you determine if you want to calculate 95% CI, the value of Z is 1.96 plus and also negative 1.96. Okay, for other values of percentage, like 98%, okay, I mean, like I mentioned just now, the common one is 90%, 90, 95, and also 99. These are the three common ones, okay, but sometimes you do find different values beside these three. So the same procedure applies. If 0. Let's say you want to calculate 0. Let's say 95%, 0.95, correct? If 90%, 90% means 0.9. Okay, 0.9 means the area under the curve will be 0.9. Okay, if you cut the graph into half, 0.9 divided by 2 means that each area will be 0.45, correct? Okay, so 0.45, then you need to refer to the Z table, which one is closest to 0.45. Okay, so if we go back to this table here, okay, I'm not sure whether you can find 0.45, okay, 0.45, okay, the closest one will be here, 1.64. Okay, you can see here. Just now we mentioned that if 90% confidence interval, half side will be 0.45. Okay, 0.45. You can find the closest one is actually between these two. Okay, this one has not reached 0.45, but it is 0.4495. If you run up to 2 decimal, then you can use this one. Okay, so this is almost the closest to 0.45, which is 1.64. So 90% confidence interval, the Z value will be plus minus 1.64. Okay, 1.64. So, and then you can use the same principle, okay, for other value of confidence interval value. Okay, you take the value, divide by 2, and find the value closest to that. So that will represent, so for example, just now 90% cut into 2, 0.45. 0.45, the closest one is this one, 0.4495. So that value represent under 1.64. Okay, so I hope you get this idea of this confidence interval punya concept. Okay, so here we look at one example first. Okay, so again, remember that this is still under the sigma is known, meaning that we are going to use the Z distribution first. Okay, so you are given this information first, so you need to know what is the sample size. Okay, if you look at the formula just now, you need to fill in all these numbers. Okay, what is the X bar? What is the standard deviation of the population? What is the sample size? And then for Z, you need to know what is the desired level of confidence interval. If 95%, the value will be 1.96. If 90% just now, we know that it will be 1.64. For other values, okay, depends on the, so you can refer to the table. Okay, so this one, it will be, okay, so your N is 256. Okay, the mean will be 45420. The sigma, standard deviation of this population, you can see that the word here is mentioned. Standard deviation of population, which is the sigma, is 2050. Okay, and then so you want to calculate, so what is the population mean? Okay, what is the reasonable range of values for the population mean? What do these values mean? Okay, so of course this what is the population mean? We say that we do not know lah. Okay, but what you can do is, our best estimate is using the sample mean. Okay, so so this is what the question wants you to actually think. What is the population mean? We do not know. Okay, but our best estimate is using the point estimate, which is the X bar, which is equal to 45,420. Okay, and then so let's say we want to calculate 95% CI for this particular question. Okay, so we know that just now how we determine the Z value, which is 1.96. So the rest is you just plug in. Okay, so X bar is the sample mean. Z, we know that it will be plus minus 1.96. And then the sigma, sample standard deviation, divided by square root of the sample size N. Okay, so the confidence limit are meaning 45,420 is the mean, minus or plus with this margin of error. So 1.96 multiplied by 2050 divided by square root of 256. So you should get the lower boundary, which is 45,169, and the upper boundary will be 45,671. Okay, so this is your confidence interval value. Okay, so it's a simple, straightforward formula for you to calculate. Okay, and then how do you interpret? Okay, so first is the calculation part. Okay, so what does this mean? Okay, so what does 95% confidence interval means? Okay, so just now we mentioned that our confidence interval from this simple calculation is for between 45,169 up to 45,671. Okay, so you can refer to this simple, straightforward interpretation. Okay, select many sample of 256 managers, compute the 95% interval. Okay, so basically this is one interval. Okay, so this is one interval from a sample of 256 managers. Okay, so meaning that from this pool of managers, you take 256. Okay, so basically, if you okay, so if you look at this definition here, select many samples, meaning that what you find here, this one is just one of, if you repeat the process many times, okay, meaning that this is, let's say, if you have a pool, so let's say like this is the pool of managers, okay, so let's say they are, let's say from this, so let's say you have 1,000 managers, so this is 256, this is another 256 that you can take, this is another 256. So if you repeat the process many times, so this is one attempt, meaning one interval. Okay, so what the statement means in this part here, select many samples, meaning you can take first round, you take 256 from that pool, and then you take another 256 from the same pool, from the same population. You repeat the process. Every time you collect 256 sample, you determine what is the confidence interval. And then you repeat the process many times. And okay, so the idea of CI is that you come from those many intervals. You can see from this simple slide here. Okay, if you repeat the process many times, how many times? Okay, of course, in the real world, okay, you don't know, I mean, you're not expected to repeat this process like 1,000 times, maybe a few times, okay, or maybe even one time should be sufficient. Okay, but the idea of confidence interval, if you repeat this process several times, okay, or many times, so this, you can see this one line here means this is the first confidence interval, and then you repeat the process. This is another interval that you can calculate. So when you repeat the process many times, you can see that, okay, sometimes the value of the, okay, so let's say this is the value of the population mean. Okay, so the value of the population mean, okay, happen to be inside the interval how many times? So it is inside this interval, it is inside this interval, it is inside this interval, okay, inside this, but not inside this interval, it is inside this interval. Okay, so if you repeat the process many times, 95% of the interval that you construct will contain the value of the mu. Okay, so it can be this interval, it can be this interval. Okay, so when you repeat the process many times, so meaning that you will calculate different intervals from different sample. Okay, so this is one interval, and this interval happens to be, this is the lower boundary, this is the upper boundary, and because the mu is here, it is inside the interval. So every interval that you calculate except this one. This one, the value of the mu is outside because the mu is here, but the interval value, the lower and the upper boundary is not within the value of the mu. Okay, but if you are not really, I mean, fully understand this concept yet, okay, so the idea of confidence interval, so this is the one highlighted in bold will be the definition. Okay, how to, if you can refer to your textbook on this topic, okay, so you will find, okay, also another concept of this confidence interval, okay, how to define or how to interpret the confidence interval. Okay, conversely, 5% does not contain, okay, which is like, for example, this one, this could be the 5%. When you repeat the process many times, 95% of the interval will include the population mean, except the remaining 5%. Okay, so that is when you are using, when the sigma is known. Okay, so let me stop here first. Okay, and then because in this next slide, we are going to use the T distribution. Okay, so I think we look at maybe one or two examples from the book. Okay, let me. Okay, so let's look at question. We use the one that has answer at the back. Okay. Okay, question number 5 here. I think it's quite simple and straightforward. Okay. The survey of 49 randomly selected. So 49 will be your sample size. The mean X bar is 20. The population standard deviation is 5. Okay. So it is the population distribution with a standard deviation of 5. Okay. So this is the standard deviation. What is the point estimate? Okay. Just now we mentioned that point estimate is is referring to either X bar or so. What is the point estimate of population mean? The point estimate will be 20 lah, which is the X bar. Okay, so explain what it indicates. Okay, it just indicates the mean of the population will be 20. Okay, so question B. Okay, you can calculate this and then you can check the answer at the back. Okay, but what I can show simply from this example. Okay, if you want to calculate 95% CI, so the formula just now is X bar, okay, plus minus, okay, Z multiplied by the sigma divided by n square root. Okay, so that is the simple formula. So you just plug in, accept the value of Z. Okay, Z you need to refer to the confidence value. So 95% just now, we know that the value is 1.96. Okay, so you just plug in, x bar is 20 plus minus 1.96 multiplied by sigma, which is 5, okay, divided by square root of 49, okay, 49 square root, which is 7 again, okay, but just to show that this is the formula. So 20 plus minus 1.96 multiplied by 5 over square root of 49. Then solve this, okay, you should get your lower boundary and also your upper boundary. So this will be your lower boundary, okay, comma, and this will be your upper boundary, okay. So you can check the answers at the back, okay. I'm sure you have answers for all the odd number questions, okay. For question number 2, it will be the same, okay. So 95% is again 1.96, okay. What about 99%? So how do you determine the value of the Z value for 99%? Okay, so if you refer to the table, okay, 99%, okay, recall just now, okay, how do you, okay, if 99% means that the area under the curve will be 0.99. So it is the center, okay, so 99% CI means the area under the curve between the lower and the upper boundary, okay, this area under the curve, okay, this area will be 0.99, correct? Okay, so this will be 0.99. So the next step is just to cut or divide into half. So 0.99 divided by 2, okay, 0.99 divided by 2, and this value you're going to refer to the table, find the nearest one to the half of the 0.99, okay? So 0.99 divided by 2, you get 0.495. Okay, so 0.495 is the one that we want to locate from the table. So which one is the nearest to 0.495? Okay, so this one we obtain, okay, 99% CI means the area under the curve is 0.99. So half of the 0.99 is 0.495. So find the area nearest to 0.495. So the one that I can find here, the nearest to 0.95 is somewhere here. So I think we can use this one, 0.4949. Okay, 0.49. So let me increase the screen size here. Okay, so 0.4949 will be the nearest to 0.495. So what is the corresponding Z value? It will be 2.57. Okay, so we can say that for 99% CI, for 99%, the Z value will be 2.57. Okay, so how do I know that? Okay, again, you find the nearest to 0.495. The one that we can use is 0.4949. You round up to 3 decimal place, you get 0.495. So the corresponding value is 2.5, and then go to the top, 2.57. Okay, so for that particular exercise just now, if you want to calculate 99% CI, the Z value that you can use is 2.57. Okay, that will also give you the correct answer as well. Okay, so I think that's it for today. Okay.